Hello and good day to everyone watching. For today, I have invited different engineers to explain one of the most used aircraft for training pilots, the Cessna 172. Our chosen guests are Engineer Cruz, Engineer Decena, Engineer Uriel, Engineer Cayabyab, Engineer Cruz, and Engineer Carpena.
Join us in exploring the wonders of Cessna 172.
So to begin with, as you can see on this figure, the numbers indicate specific parts of Cessna 170. Number 1 is the firewall, 2 wing attachment points, 3 cockpit, 4 door opening, 5 windshield, 6 tail cone, 7 bulkhead, 8 stringers, 9 formers, 10 stress plate, and lastly are motors. To discuss the first part of the Cessna 170, here is Engineer Cruz.
So thank you for that introduction, engineer. So, a little bit of description about the Cessna 172. So it is an American four-seat, single-engine, high-wing, fixed-wing aircraft made by the Cessna Aircraft Company, first flown in 1955. So it's one of the most popular aircraft with over 44,000 models produced. It is the aeronautics school's choice in training pilots and considered as one of the best training aircraft for pilots because of several reasons. So firstly, it is easy to fly and durable enough to enter the landing of a beginner pilot, and because it's a high-wing plane, it allows to have an unobstructed view. So the Cessna underwent minimum to non-configuration at all during its 70 years of production, which speaks a lot to the quality of its initial design. So we choose to pick the fuselage that has a semi-monocoque construction of the Cessna 172 and discuss its given parts. So firstly is the firewall. So why do aircrafts need a firewall? So essentially, it is a fire-resistant bulkhead that separates the engine compartment from the cockpit area. So it is an important component in the aircraft. So it must be constructed well enough to not allow any hazardous substances of gas, liquid, or flames to pass through it. So it must be both resistant to corrosion and flames. In an event should a fire occur in the engine compartment, which is in front of the Cessna 172, the firewall will protect the aircraft's occupants from the flames long enough for an emergency landing to be executed. And here we have Engineer Decena for the next part of the fuselage.
Thank you, Engineer Cruz. So for the second part of Cessna 170, we will have the wing attachment points. So what is wing attachment points? It is basically the wings of an aircraft that can be attached to the fuselage at the top, mid-fuselage, or at the bottom. Since the Cessna 172 is a high wing plane, the wings are connected to the top of the fuselage and are located on both sides of the aircraft. They may extend perpendicular to the horizontal plane of the fuselage or can angle up or down slightly. Moving on to the third part, and I feel like you all know what this is called for. Yes, you're right. This is the cockpit, or also known as flight deck. So what is the cockpit? This is basically the part of the aircraft that offers visibility to the front and sides, houses up the pilots, passengers, contains flight controls, and instruments of the aircraft. This is the area where the pilots controls the aircraft. Being a lightweight plane, the Cessna 172 can only hold 4 people and the maximum gross weight capacity of 2,550 pounds or 1,150 kilograms. To discuss the part and take part, we will have Engineer Uriel.
Thank you, Engineer Decena. The next part of the fuselage is the door opening. The door opening is on the exterior part of the fuselage. It does not require any tools to be opened or closed. It is where you can enter or exit the aircraft. It represents the start or end of one's time being on board of an aircraft. And passing through the door opening can signify the beginning of a new trip or the excitement to have arrived somewhere new. The next part of the fuselage is the windshield. Windshields are designed to withstand high pressure environments that normal windows couldn't function in. Light airplanes like the Cessna 172 employs windows or transparencies made out of acrylic, the most common of which is plexiglass. The sizes of windshields ranges from 8-inch thick for lighter and slower models to quarter-inch or 3/16-inch thicknesses for general aviation airplanes. When you opt for thicker windshields, you are getting two things. First is the better protection from birds and debris. Second is the greater sound deadening capability. There is no drawback to having thinner windows, aside from having greater cabin noise. The next parts of the fuselage are the tail cone and the bulkhead that will be discussed by Engineer Cayabyab.
Thank you, Engineer Uriel. Number 6. Tail cone. Tail cone is the rearmost part of an aircraft fuselage. The cone section of the exhaust system of a gas turbine engine used to produce the correct change of area of the duct through which the exhaust gases leave the engine. The tail cone serves to close and streamline the aft end of most fuselage. The cone is made up of structural members like those of fuselage. However, cones are usually of lighter construction since they receive less stress than the fuselage. Number 7. Bulkheads. A bulkhead is a material partition such as a wall, curtain, or screen that divides an airplane into various classes or sections. Bulkheads can be found throughout the plane, separating the seats from the galley and lavatory areas. A bulkhead is more than often a wall, but a curtain or screen. Bulkheads are off-pressure bulkheads can be either curved, which reduces the amount of metal needed at the cost of reducing the usable space in the airliner, or flat, which gives more internal space but also more weight. And for the next part, we have Engineer Dela Cruz to explain number 8 and 9.
Good day everyone, I'm Engineer Dela Cruz and let's talk about the stringers and formers. A stringer is a narrow strip of material to which airplane skin is connected in aircraft construction. Stringers are coupled to formers, also known as frames, in the fuselage and run in the plane's longitudinal orientation. Stringers run lengthwise longitudinally along the airplane's fuselage or span-wise of a wing and are commonly mistaken with or referred to interchangeably as longer ones. Their function is to transfer loads and stresses from the aircraft screen to the formers as structural components. And next, let's talk about formers. A former is a structural part of an aircraft fuselage with a series running from the nose to the empennage and normally perpendicular to the aircraft's longitudinal axis. Formers are usually linked to the longerons, which support the aircraft skin. Formers are used to determine the shape of a fuselage and to shorten the column length of the stringers in order to prevent instability. Formers are usually linked to the longerons, which supports the aircraft skin. So what is the difference between bulkhead and formers? A former is a partial frame shaped like an arc rather than a circle. And yes, bulkhead could mean a heavy frame. And next, let's have Engineer Carpena.
Thank you, John Matthew. The outer surface of an airplane which covers much of its wings and fuselage is known as the skin. The fuselage is a semi-monocoque structure made of skin to carry cabin pressure and shear loads. The skin of an aircraft is light, thin, and strong. Together with structural airframe, it holds the plane together and keeps the inside pressure intact. A longeron, stringer, or stiffener in aircraft construction is a thin strip of metal to which the airplane skin is fastened. They are in charge of transferring the loads that operate on the skin to the frames. Longerons travel span-wise and attach between the ribs of the wing and horizontal stabilizer. The major function of the ribs and spar is to transmit the bending stress operating the wings to them. The names longeron and stringer are sometimes interchanged. However, there is a historical distinction between the two words. Longeron are longitudinal components in a fuselage that are few in numbers and run the whole length of the fuselage. The longeron method also necessitates a narrow spacing between fuselage frames. The longitudinal members are referred to as stringers if they are many and are only put between the two frames. The longitudinal members are smaller and the frames are positioned more apart in the stringer system. When opposed to stringers, longerons have a bigger cross-section. The stringer system is more popular on big contemporary aircraft because it's more weight efficient, although being more difficult to create and analyze. Stringers and longerons are used in tandem by some aircraft.
And that brings us to the end. We would like to thank everyone watching for your time and attention, and we hope that you find our presentation about the Cessna 172 informative.